Hey everybody, my name is Daniel Hansen,
And I'm Alexander Bloom.
and today we're going to be discussing the Singleton design pattern.
Alright, so first off, what is a singleton? A singleton's intent is to ensure that a class has only one instance. It implies that a singleton's instance should be reusable. The only way to keep a singleton's instance for future reuse is to store it in a static or global context. What that basically means is that it is a globally available class. Alright. Singletons can only instantiate themselves through a public method, which initializes its private constructor, which is another feature of singletons in and of themselves. There are several ways to instantiate a singleton, but the two most important things that you should be familiar with is eager instantiation and lazy instantiation. Eager instantiation is where the singleton is initialized at the beginning of the program, and lazy instantiation is where a singleton is implemented only when it is called.
Alright, so now that we talked about what a singleton is, let's discuss a little bit about how we can actually implement this singleton design pattern. So there are 5 generic steps for any kind of singleton instantiation. First is you want to make the singleton class a public class so it is accessible all throughout the program. The second is to make sure that its constructor is private. That way you actually can't create the singleton in more than one instance. This is what's going to give it the singleton dynamic of only being able to be created once, is by making this constructor private, and by the third step, making the getInstance method public and static. What this is going to do is going to make the getInstance readily available all throughout the program. And there are 2 essential characteristics to the getInstance method. First, when you call it, it's going to check if the singleton has already been created. If it hasn't, then it will use its private constructor to create it. Otherwise, if there's already an instance of the singleton, it's not going to create it. It's just going to return the state of the singleton, thus preventing more than one instance of the singleton. Here is a coding example of the singleton implementation. So as you can see, this is a lazy singleton instantiation. You can see that its class is public and that its instance, or the state of the singleton, is private. That way it can only be accessed through the getInstance, and its constructor is also private, only being able to be accessed through the getInstance method. Now you can see the lazy singleton's getInstance method is public and static, therefore it's able to be accessed all throughout the program and changed all throughout the program. The same instance will be changed. And so what this is going to do is since it's a lazy instantiation, it's going to fire only when necessary. So it will, when they fire the getInstance method, is going to check if an instance has already been created, and then it will, if it hasn't been created, it will create the singleton class, making sure, as you can see, the synchronized. Don't get too confused by that. That's just preventing multi-threading. So it just throttles the access to the singleton so that it doesn't have multi-threading collisions, which we'll talk about a little bit later. And then it will return the state of the singleton.
Alright, so what are the pros? The private access to the constructor prevents clients from creating instances accidentally. The provided public instance method creates the sole instance on demand and provides easy access to the sole instance from everywhere. So what does that mean? It basically means that there is only one instance of the singleton. You can force only one point of access at a time. Optimization is also really good because you don't have to loop through multiple objects to get to the singleton that you need. Global access to the volatile variables within the class. It is restricted. That means it is checked by the class itself to make sure that the inputs are valid, depending on your implementation. And then lazy initialization is created only if necessary, which is also very useful for conserving system resources.
What are the cons? So what are the cons to using a singleton? The cons of using a singleton are very similar to the cons of using a global variable, since the singleton is globally accessible. First of all, it can be very hard to track the state of the singleton all throughout the code. Since it's globally accessible, that means methods or other variables can change the state of the singleton, and that can be very hard to keep track, especially if you have a lot of code, lots of lines of code, and if you're using the singleton in several different areas, it can become very confusing and you can get lost very quickly. Secondly, the singleton state might change unexpectedly depending on the method that you're using and the order of them. For example, maybe there's one method that relies on the singleton state to be in a certain way, but the user decides to implement a different method that changes the state of the singleton before they use that method, the first method. Already you can see it's becoming very confusing and be very hard to keep track of, and it can create many issues and can cause the program to crash if you're not careful in its implementation or in its error checking. Also, the singleton can create hidden dependencies. Once again, since it's globally available, that means it can be accessed and used all throughout the code. Many methods or functions, variables, and implementations can become reliant on the singleton being used. So if you decide later on in your code that you actually don't need a singleton, it can be very hard to get rid of, since it will cause lots of errors and it'll cause a lot of bugs and will require a lot of debugging expertise in order to locate the problems and successfully remove the singleton after you've already created the program using it. Lastly, the singleton can cause collisions within multi-threading. Since a singleton is only one instance, if several people want to change the state of the singleton, it can create an issue, since there is only one singleton. Therefore, it becomes a race to see who changes the singleton first, which can of course cause crashing and other problems. And so the best way to avoid this issue is to throttle the user access, to make it so that only one thread and only one person can change the singleton at a time. Once again, this is only necessary if the singleton is volatile or is able to be changed.
All right, so recommendations. Singletons really only should be used when absolutely necessary. It is good for replacing global variables, and a singleton is very useful for making sure that the globally accessible information isn't being filled with garbage or being modified by people who shouldn't modify it. A couple good examples of a place to use a singleton would be like when you're doing error logging, because there's only one log that you should be putting stuff into, and recycling threads on something like C++.
Well, thank you very much for listening to our presentation, and good luck on the test.